So I've had some requests to describe my power hammer. I got a YouTube video coming. I'm just going to give you a quick rundown real quick for those of you that care. We'll start at the bottom. The base plate's made out of an 1.5 inch thick piece of steel. Got the scrap yard, the anvil, and I know this comes tricky to get that big of a piece of steel. You can see here it's actually layered 3/8 and 1 inch pieces of steel that are just layered together and like a club sandwich and welded together. I cut out alternate windows as I went so I could plug weld as I stacked them up to build additional strength. So there's plug welds here and up in here. These are just the face plates. You can see the dimensions here for that. The dies are all made from hammerheads, just old sledgehammers, welded onto a plate with a bevel on it, and you're not going to see that. There we go. So they slide in there. Lots of grease in there. And there's just 2 square nuts on either side. Only the bottom dies are replaceable. You can see I've got a peen head and the top, and then I got 2 flat plates. I use this one for punching and drifting and some cutting. The top die is welded on, but it's again just sledgehammer head turned sideways. That way it gives me both a drawing side and a flat side. The ram itself is 4 inches by 3 inches by 11 inches, and it's 68 pounds for everything from there to somewhere in here. The toggles themselves here are 7 inch by 2.5 inch, and then these are, I think, 1/2 inch or 5/16, and then 5/8 or 3/4 inch bolts here, and then these toggles are just 3/8 thick. That's right. And for the eyelets in here, I use those weld-on tractor bolt eyelets, the fish eyes. I don't know if that really shows up very well. So they kind of move around in all directions. It gives me lots of play. The all-thread bolt here is 17 inches long. So between the 2 toggle eyes, I just welded a piece of pipe in here for that bolt to thread through, so I can adjust the height of the whole assembly. Makes it kind of nice. The main support system is a 5 inch by 5 inch square tubing. I think it's 1/8 inch or 1/4 inch wall, I forget. And then you can tell I reinforced the crap out of it with angle iron, just because I like to overbuild things. The whole thing is 77 inches tall. I think that is really kind of short. I'll explain that in a second. The motor I use is a 1.5 horsepower with 1725 RPM. It's actually compressor duty, underpowered, because it's not designed to start under load, so it kind of bogs down if you really stomp on the pedal. I had a farm duty, but I didn't have this guy trued up enough, and the vibration caused it to crack back here. This guy is just a 2 inch diameter by, I think it's about 3.5 inches, and then this part back here is actually just a pulley wheel that I welded it to. The tire here, I just used, well, I'll show you back here. It's just a weld-on hub. And then this piece here is actually a piece of angle iron, and then this kind of flare back here is another piece of angle iron welded to it, and it's cut in and socketed, welded into there. That's not the right term. There is the type of tire I used. I was trying to build a different style, more the Appalachian with the kind of nodding donkey arm. So I kind of had this very expensive plate left over that I welded and bolted into this system. So there's actually spacers back here that keep it off of the pulley or the tire hub, and allow a little extra space, and then there's some extra spacers there to keep that pillow block off of those nuts. Unfortunately, I think it needs to be a whole lot taller. You can see on my counterweights here, I am rubbing the back side of these bolts and the side of that plate. Yeah, you can kind of see it that way. So this whole thing needs to be taller and maybe a little bit more spaced out. Then these guys here are just 2,500 pound axle springs, 3-piece, and then I had the axle shop drill through them, and then actually the ram itself is threaded, so the springs are just clean drilled and the ram is threaded. Like I said, the foot pedal can be adjusted with this turnbuckle here in the middle, and then the foot pedal here is pivoted down at this point, and this arm attaches to the teeter-totter sort of mechanism that the motor and brake are on. So there's actually some pipe in here that I've greased and then welded nuts on the end. Get some nice action. I had a friend with a ring roller, so I rolled this nice round bar here for that. Really, the other problem I've kind of encountered, and I'm not sure if it's due to the action or the fact that these are the bolts that are getting hit, but most of these bolts tend to work themselves loose. So I put cotter pins in these. I have the problem with this, but I haven't put pins in them, as well as this side of the spring comes loose, but not the other side. I'm not sure if that's due to the action or not. I have had to reinforce most of the guide sleeve. I think it needs to be taller and beefier. You can see I added these, but not on the back side. There is a lot of play in that. Some of that was designed because I'm not a machinist, so I wanted that kind of sloppy tolerance to allow it to work, but it really needs to be tighter, because what that does is, as the hammer works, it creates a rocking motion, and it takes nice square pieces and starts stretching them out and making them kind of elongated. It is what it is. It's better than nothing at all. And then I just have a 20 amp switch. Okay, get the broom out of there. So it just goes straight to the plug, to the switch, and up to the motor. This is just a standard garage door spring that you'd find on the older garage doors. It's not the torsion style. It's where you have the big long ones that help pull out the door up. I think that pretty well covers it. You all know how tire hammer more or less works, and if you have any additional questions, let me know. Thanks.